Welcome. In this module, we'll get started getting our hands on Apache Spark. So we are going to take a look at what is RDD, right? We talked about it in the first video, a resilient distributed data set. So we'll take a deeper look at it. We'll look at what is lazy evaluation and what are the difference between transformation and action in Spark, and then look into the Spark execution workflow. Let's get started. RDD or Resilient Distributed Dataset is Spark's fundamental data structure. Okay, so data set in itself means collection of data. So it could be a collection of string, collection of integers, or several rows of a relational database. That's one way to look at it. So what is so special about RDD is it's an encapsulation around a very large data set. So what happens is you can have, so you are creating a data frame as a RDD. So within, so Spark can sort of distribute it across multiple worker nodes, right? So most of the tasks that we do in Spark will be about creating an RDD, transforming an existing RDD, or calling operation on RDD to compute an output. So under the hood, so that's what the visualization is telling you. Spark will have data distributed across the clusters and parallelize the computation operation, right? So it's a unified data processing engine. So when we write our code, we don't have to take care of this distribution that is going to happen. So the whole data structure itself is set in a way so that it's distributed. So just to very quickly recap with regard to the Dask library, right? So we talked about how it uses blocked algorithms, etc. So RDDs are the way in which Spark is using distributed system, right? So it essentially creates a data structure. So you are not worried about how to chunk it, etc. So it will take care of all the distributed processing. So one way to think of your resilient distributed data set is it's a fault tolerant collection of objects. So because it's collection of data that can be operated on in parallel, right? So parallelizing operations and distributed doing it parallelizing how? Because multiple workers are parallelly doing your operation, right? So this is a very important thing to understand. So we'll work on some of the coding for RDD so that you can understand it better, but it helps to see this visual. So there are two types of RDD operation. One is called the transformations, the other is action. So transformation are function applied to the data that is read into an RDD to create a new RDD. For example, filtering, right? It returns an RDD which is a subset of data in the original RDD. So typically transformations are done as lazy operations and not executed immediately, whereas action is essentially compute a result based on an RDD. So for example, if you are doing first on RDD, so think of RDD as a data frame, right? So RDD, so if you are doing first, it returns the first element in an RDD. So most of the actions are implemented as eager operations, which means they are executed immediately. So we saw what are the two RDD operations, right? One is your transformations and your action. So lazy evaluation is a very, very important concept. So we talked about it even when we talked about the Dask library. So it's a very efficient way to deal with big data. So when we are talking about big data, one of the things that we fail sometimes forget is your data is essentially terabytes of data, right? So you are doing filtering on terabytes of data, you are doing mathematical computation like standard deviation over terabytes of data, etc. So all of these simple operations that we were so used to doing in pandas for a small CSV file, it's no longer possible to do it at that scale because you can't load your entire data into your memory to do that, right? So what Spark does is it essentially the lazy evaluation tells us what the operation actually is. Spark will only do something when it's forced to. right? So all the transformations are lazy, which means you can accumulate multiple transformations, but the execution of it does not happen until an action is called. Okay, so that is very important. So transformations are not done until an action is called. Okay, so transformation creates a new RDD from an existing RDD. So you can do your filter, you can do your map, etc. But only when you trigger all the operations, when you create your action, which is essentially one of the methods, one of the RDD operation. So action returns the result to the Spark driver, which is your main program, right? So actions are usually eager evaluation. Eager is it gets executed immediately. So here are some sample transformation and action commands. We will see some of them when we start coding it. Here I have just listed it. So transformation, as we have seen, applies logic to the data set to change it. So some of the examples are mapping, which is pass every element through a function, very similar to your data frame map. You can do filter certain elements, sample, so return just a subset of the data set, etc. These are transformation. Whereas action is executes all the pending transformation and returns the results to the driver. So some examples of how do you trigger this eager evaluation, right? Actions are all executed immediately. So when you do count, so it returns a number of elements in the RDD. Or if you do reduce, so it returns an aggregation. If you do collect, returns the results to the driver. We most often don't use collect as often. So similar to the first, you can also do take n, returns the n rows to the driver. So your action all executes all the pending transformation, because you can apply multiple transformation. We'll talk about it in the execution workflow in just a couple of slides, how the whole flow looks like, right? When we do the action, all of the pending transformation gets processed and the results are returned to the driver. So we also need to familiarize ourselves with some of the Spark terminologies. So Spark context is the main entry point to your Spark core. So that is your Spark driver, right? So it establishes a connection to the Spark execution environment. So it acts as a master of your Spark application. So whenever we say Spark context, right? SC or Spark context is the main entry point to your Spark core. Then you have your Spark application. So Spark application is a self-contained computation that runs user-supplied code to compute a result. Even when there is no job running, Spark application can have a process running on behalf of it. So application built on Spark is typically a Spark application. Then you have a task. Task is a unit of work which is sent to the executor. Every stage has some task. One task per partition. Okay. Then you have a Spark job, which parallel computation consisting of multiple tasks is called a job. And then you have stages. So each job is divided into small sets of tasks which are known as stages. So we'll see a visual diagram in the next slide to walk us through the execution workflow of Spark, so that you understand each of these terminology better. So this slide sort of gives you the execution workflow of Spark. Okay. So all of your data is in RDDs, your resilient distributed data set. So then you are doing some joining of two RDDs, group by, filter, right? So each of it is a transformation. So when the job enters the driver, the driver converts the code into a logical directed acyclic graph. So this is your DAG. So any transformation that you do, Spark internally converts it into a DAG, right? So it will tell that in order to do this, you have to, these are the steps. It splits the graphs into stages of task, all right? So furthermore, it converts the DAG into physical execution plan with the set of stages, right? So here you can see that not only are we doing the graph, but it also tells in what steps should the DAG be executed. So this is the stages that we talked about in the earlier slide. Meanwhile, it also creates a small execution unit under each stage referred to as the task. Then it collects all the tasks and sends it to the cluster. Right. So the DAG scheduler, so whenever you are just writing this piece of code, right? So you are writing how to join your RDDs, do group by or filter. So once you create an action, the whole so while you do your transformation itself, your DAG will get updated, right? So your directed acyclic graph actually gets done. So it splits the graph into stages of tasks, then submits each stage as it's ready. So then each of the stages consists of multiple tasks. It is the driver program that talks to the cluster managers and negotiate for resource. So one of the very important part whenever you are doing distributed data processing is cluster management, right? So there is a cluster manager which essentially negotiates for resources. After this, cluster manager launches executors on behalf of the driver. So at this point, based on the data, placement driver sends tasks to the cluster manager. So the executors register themselves with the driver operation before executors begin execution. So the driver has the holistic view of all the executors. So this is your task scheduler. So once the DAG is created, the task set is created, right? So then the driver program essentially creates how the resources needs to be done. So it launches tasks via the cluster manager. So any kind of retries or struggling tasks, it knows what's happening. Then each of the tasks is done by your worker node, right? So it executes the task and then returns the update back into the program. So each of it, as we write code, I will walk you through how the DAG gets formed, etc. But this is to give you an overview of the Spark execution workflow. So to summarize, in this module, we have gotten started with Apache Spark. We saw what was a resilient distributed data set, RDD. We took a deeper look into what is lazy evaluation, understood transformation and action, and we also concluded by looking at the Spark execution workflow. All right, so in the next video, we are going to get coding hands-on on Spark. So I'll see you in the next video. Thank you.